Welcome back, everyone, to another episode of the Crypto and Coffee podcast. Right, I'm your host Giordano, joined by Cordell and David as per usual. And in today's episode, we have a Web 4.0 topic, and we're going to be talking a little bit about quantum networking, quantum internet, and the future of search with AI. Right, so grab your cup of coffee, tea, water, and enjoy the rest of the episode as per usual. Oh, Cordell, one of the things I want to start off, as we always start off with a very vague question as per usual, right? For the people that are not very tech savvy, what is quantum networking, just in simple terms?
Yeah, okay. I think even before that, you'd probably need to go back and describe a little bit about quantum computing, and understand, because like to really understand the whole thing behind, quantum computing and then how by extension that's going to lead to quantum networking and eventually the quantum internet and the future of the internet, future of search engines. You need to understand a little bit about the quantum physics principles behind it. And, I'll try and do it without chasing anybody away. But and I think we did mention this when we first talked about quantum computing, episode, I don't know, 10, whatever it was. But the main thing to understand and the big difference between classical computing and quantum computing is the qubit. Whereas with classical computing, we've done everything with binary code, one or a zero, on, off. That's it. So, but that's not how quantum computing works. Quantum computing works with something called the qubit, which is essentially, you got to think of it more as like, a spinning coin where you don't know if it's heads or tails until you actually stop it and measure it. And at the same time, it actually exists in both states. So that's called something that we call superposition. The concept of superposition is being able to occupy two states at the same time. And that could almost mean actually being in the same place, two different places at once, kind of, with that principle of superposition. So the qubit, quantum computing is all based on this. So it's all based on the fact that, we have this principle of superposition and another principle that Einstein once called, he called it spooky action at a distance, which was quantum entanglement, meaning I could hold a particle here in Montreal and David down there in Georgia could hold another particle, and something that I do to my particle would instantaneously have an effect on David's particle. So that's the whole principle. So it's action at a distance, and it can happen really at very long distances. So this is how quantum computing works. And the next thing you need to understand about that, because this is really the underpinning for all of quantum networking, future cybersecurity, internet, and everything, is that it is absolutely impossible. It is against the laws of physics to make a copy of anything if you don't know its quantum state. The quantum state meaning, where is it? Where is it moving? All of the quantum characteristics. If you don't know that, you cannot copy it. So think about what that means for computing, right? So if you were to try to intercept my message going to David through our quantum entanglement, you wouldn't be able to do anything about it, because like I would know the second you breached it, because something would happen to it. So it just, you cannot copy it. So that's what's really, really important. You need to understand that concept here, between superposition and quantum entanglement and the qubit versus the normal bit. So like, that's really the most important part. So, I think that is what we need to like try and get the Star Trek kind of stuff into your head behind this stuff, because that's really how this technology is built and how it's going to pretty much affect the quantum network. So I don't know if that came anywhere close to answering your question, Gio, but I think it was important just to have that kind of introduction out there. Any other questions like about the physics behind it? Let's just say, are there any other questions that you think we should answer about the physics before addressing the
Personally,
networking
no.
part?
It should be very straightforward from what you've said just now, and I think it's a good explanation for what you have What I do want to know is like, what is your idea, not ideal, but like, what is your actual concept on like the quantum internet, right? Compared to like the normal internet.
Okay, well, so let's let's just take a step, like, where are we today and everything that's going on. So the idea behind the quantum internet and quantum networking is, so we're working on quantum computers, right? And quantum computers is once again focusing on this idea of superposition, action at a distance, and quantum entanglement, and being able to encode all of this as a qubit. And that's using the quantum states, the characteristics that we have to describe a particle at the quantum level, the submicroscopic level. So right now, we have quantum computers under development. The next step here is whether you could, inside your data center or your room at IBM or wherever, you're able to locally connect multiple quantum computer processors. So you're trying to build a scalable supercomputer by hooking up multiple quantum computers. And this is probably the biggest commercial win right now. So we have a lot of tech giants out there that are using local quantum links to smaller chips. We'll call them smaller chips. And we want to link the smaller quantum computing chips. We put them together and see if we can build one massive, stable quantum computing chip. But I mean, that is like an engineering miracle masterpiece right now. So that's essentially what quantum networking is. This is what companies are working on, but it is an extreme, engineering challenge, one that we haven't obviously fully solved yet. So that's what quantum networking is.
Okay, noted. David, your thoughts?
I'm not too sure how they create the repeaters for that. Would you happen to look that up?
Question.
Yeah, I don't know the engineering there, and from what I saw, it's an engineering problem on how to do that over long distances, but I don't even know how they do that over short distances. And without knowing the full picture, there's not too much that I can say on that aspect of it, because like what would be the cost? How feasible is it with regards to the materials? How many people know how to do it? That's going to affect how easily you can get that stood up. There are a lot of questions there just from the base, because I don't know about the engineering side of it.
Yeah. I mean, it's the quantum repeaters is actually, like David just hit it right on the nose there. That's one of the biggest challenges that are absolutely they have with it, right? Is because remember what we said, right? Okay. If you want to take a signal and broadcast it or send it out, we need to amplify it, but we can't copy it because we just said that it is absolutely impossible to make a copy of something at the quantum level if we do not know its quantum state. But the very act of measuring its quantum state changes the particle. So that's why we have this issue. So the industry is currently racing to build these quantum repeaters that could somehow pass the quantum state down the line without breaking it by measuring it. So, they have some regional fiber test beds. I think I think I did read, as I was doing some research here, I think I found they do have something called the quantum grid in Chattanooga that is supposed to be like the first regional, like very localized fiber optic network that they're testing for these kind of repeaters. So very, very early stage. But yeah, I mean, that David just hit a bang on the nose there. It's the quantum repeaters that are just like, how on earth are you going to amplify the signal when you're not even able to copy it? So, I mean, that's like, I don't know. I think that's probably way beyond my armchair physics level. And David's right. Who knows how many people at this point have the enough technical expertise and plus the resources to even build this. I think it's exciting. I mean, we'll definitely see more in the next, but don't expect any miracles in the next year.
Yeah, I completely agree. And in terms of like infrastructure, I'd say like, we're a lot early in terms of like, what we can use. Like for instance, like I don't think our fiber optic cables in the modern day could necessarily handle it, or even probably satellites for that matter.
That's a very good point. And I think the what's it called? The Europe has something. Europe's been launching a satellite. I think it was called Eagle or something like that. That they're
Yeah.
trying to test quantum space beams. So yeah, I mean that's the thing is, can modern fiber optic technology, is it even adequate for this? Don't know. But testing the space beam sounds like a really cool idea. Just don't hit any Starlink satellites or anything as you're doing it, please.
And
Don't
with
want to knock
quantum
out the
network,
entire.
yeah, sorry, go ahead.
No, I was just about to make a joke. Like, you don't want to knock out like the internet to how many countries depend on, Starlink or
Mm.
anything like that. I mean, because there's still so many when you start building this stuff and testing it, you always, there's mistakes happen and certain unintended consequences usually happen. So you got to be very careful about this kind of stuff, especially when messing at the quantum level.
Yeah, because it's speaking of that, right? I think with quantum networking, it's gonna probably bring a new standard of probably security, of secureness when it comes to I guess doing communication between businesses, or even governments or institutions. Your thoughts?
Dave, go first, man.
On security, I do know security. There are about 7 different levels of security, and if you're compromised on any single one of those levels, then you're compromised. If you get access to the person's computer, then you can get the information. If you get access to the room, you can get the information. Like you probably heard about Wi-Fi and that being able to read your movements. Now, depending on how finely it can do that, it can get those keystrokes. If you don't want to go through that, then you can get those by sound. You can get those by getting a just some measuring tool under their desk to figure out where the positioning is. There are multiple ways that you can do that on even just the room level. If you go a step further than that, if you go to to their internet service provider and compromise that, or if you go to the router level, there are all sorts of different levels that you can get to the information on. So this would be something on with quantum computing, then that would be on one of the lower levels. You'd have to change how you access that. Sure, maybe most of the hacking goes with the problem between the computer and the chair, but you're not really going to be fixing that anytime soon. That's not going to get fixed up by quantum computing. With regards to the communication between different computers, then that would be the quantum networking part, and that could be changed. But if you still get access to the route, now with the internet, you have to go out to the router or to the internet service provider. Well, either one of those would be traded out in this case, and you'd be going through that quantum networking system. But the principle would still be there. If you get access to that, then you can still compromise the message. So yeah, in a way, it's going to be a little bit less accessible, but yeah, you'd still have to go through the same principles.
So let me ask you a question then, David, right? Because if we think about, today, if I send you a picture or a file by email, it's a copy, right? I am sending you a copy of what of what I have. I'm sending you a copy. So if this thing gets intercepted, right, it could be this thing could be infinitely duplicated, can be intercepted, copied in transit. So much could happen to a typical, even encrypted email or whatever that I send you. So if we're moving to, let's say, a quantum level, where instead of sending copies, I am really teleporting the actual physical state of all of the particles that make up the file or whatever. How does that change security? Because we're no longer, like me just putting a password on an email or password protecting a file. We are now essentially putting security into the entire fabric of the universe. So how will that change, any of what you just described?
Well, that depends. Would it be going one-to-one, or is there some way that could be, or is there some way where that could be sent to multiple places? And how long distance is it? Is it going to be direct to the other person, or is it going to have to go through some relayer of some sort? If it has to go through some relayer and you get access to that relayer, then that still compromises that middle section. Otherwise, you'd still have to compromise the computer. In either one of those situations, that's just one of those different levels of security. Now, maybe you knock out the middle level if you can get it to go long enough, but otherwise, if you have a repeater, then you still have that middle level there.
Yeah, but how, even if, okay, so even if, let's say, I can infiltrate the repeater or whatever, it's still in a quantum state. I mean, I thought that's the whole point behind the technology here. It doesn't matter where in the chain that this thing is intercepted. The second you were to decode it, I would know. Because you've altered the signal, right? You've now measured, that's the whole point behind, the whole quantum problem is that measuring it, which means somebody in this case intercepting it and decoding it or trying to decode it, would essentially tip me off. So I'm trying to figure out, like, even if you had access to the repeaters, how does that solve the problem? I don't see where it matters where you intercept it along the pathway. So it's like, how do you actually find a way to decode, how does this really ruin security? Or like, this is supposed to be improving security, right? Let's assume for a second we're not even using quantum computing to decode. We're just solely talking about improving security by quantum computing. This shouldn't be an issue, that somebody intercepting it at the repeaters.
Well, have you ever used a private messaging application?
Of course.
Yeah, so those encrypt the message, and it encrypts the message between two parties. What if the other party wants to release a message, or someone else gets a hand of their phone? Now, if you've never considered this, or if you've ever talked to women that would do this, or know people who would do this, a very easy way to get past those is to have a second phone. So you have the secure app here, you have your second phone here, you just record the message and you just scroll, and now you have all the information on the second phone, and you can do as much as you want with the copy. That's, now you can't screenshot the secure app. It specifically disables that, but there's still a way to get the information onto a copy and manipulate the copy. So in this case, you don't have to touch the original. You just have to get the information and copy the information.
Okay. All right. I think again, I mean, this is where this stuff starts getting very complicated, in my opinion. I mean, this is where, like, the quantum physics and all of this, just, especially when you're not a physicist, you just pretend to be one on a podcast, where it starts getting kind of complicated. But it's okay. So, I mean, and if we bring this back to a little bit to the Web3, to, the crypto universe, right? So, the way, I've also been reading that a lot of people are stealing all the public keys, is getting as many, hands-on keys as possible today, just waiting for the day where they can use the quantum computing to backwards compute private keys from a public key, right? So I know that we had this basic discussion probably 10 episodes ago. So if I bring it back to the whole cryptocurrency space here, how, I'm not going to say, like, what are your feelings or your thoughts on it, but essentially, the crypto universe, right, is at risk from this. Correct? We are at risk.
Yeah.
Okay. So if we're so at risk behind it, I think I'm just trying. I don't want to try and repeat too much of what we might have said in the in previous podcasts, but if we have bad actors are stealing and storing encrypted blockchain data today, just waiting for the day quantum computers are powerful enough to crack the RSA encryption, okay, like, so what do we do? What does it look like for post quantum cryptography in the Web3 world? So, like, what is the world? I just want to bring it back to crypto and coffee.
Yeah.
What will the Web3 world look like, or Web4, once we adapt to quantum computing? How do you think the Web3 world will change as a result of quantum computing, knowing the risks that we have right now?
David, you want to go first?
Well, the user experience would improve, and that the speed to record to the blockchain would improve, and that would be nice. But then also on the security aspect, you'd have newer chains that are built with that in mind and increase the security, increase the keys long enough that they're not going to have to worry about about the speed for the decoding there, because every single digit you add adds basically multiplies the possibilities further. Now, how many characters? I don't remember. Let's just say 200. Every single one would be multiplied by 200 for every single digit that you add then. So 200 by 200 by 200 by 200 by 200. Now, if you've ever seen that chessboard problem of doubling on every space, and then you get the entire king's kingdom by the end of it, well, that's going to increase very, very quickly. Now, that's just starting from 1 grain of rice to the entire kingdom in 64 squares. So multiplying by 200, you've got a pretty fast growth there. I'm pretty sure you could add enough characters to slow things down enough that it'll make it hard for attackers again. So I'm not too worried about the security there. Now, with regards to older chains, yes, Bitcoin probably not going to move fast enough. Ethereum probably not going to move fast enough. Like Vitalik Buterin could come in himself and say, "Hey guys, we need to change this." And whenever he does that, and then it takes multiple months for the vote to go through, and then the change happens. So yeah, I don't expect either of them to respond quickly enough, assuming that this comes out like tomorrow. Now, with regards to newer chains, they're just going to be built with those things in mind. So they're going to have additional security hardening. They're going to take advantage of the speed from day one. So it would just be an evolution of things. Now, you'd have the better speed, which is part of the user experience problem now, and you'd have better security with regards to the newer technology.
Okay.
Cool.
I personally think it's dependent on how it's adopted. I think that at the end of the day, it really depends on how fast that we can really protect or adapt to the fastness of it. So let's say, for instance, in a security standpoint, right? Quantum computing can probably open or unencrypt, whatever the case may be. But however, it depends on how fast the AI agents or even the developers can really protect against it. I think quantum computing can probably speed up the communication between whatever and the actual nodes itself, from what I understand. And yeah.
Okay, so at this point, a lot of the layer ones, right? If we we're pretty much talking about Bitcoin, Ethereum, Solana. So they are going to have to adapt. All right, they're going to have to transition to a post-quantum cryptography kind of thing. So are you guys able to comment or describe how L1 layer ones are going to have to change as a result? What does the industry need to really do? What are they doing today, and where do they need to go to protect themselves more? So do you guys have an idea of how the layer ones are trying to change and adapt to quantum computing? I'm really curious about this because I have some basic ideas, but I'm not going to claim to be an expert at how layer ones, what their research and development is on right now. Maybe you guys have a better idea than I do.
David, you want to take this one?
Maybe not.
Yeah,
Go ahead. Sorry.
With Bitcoin, they've talked about it. They saw quantum computing coming, and several people said that it would be a problem, and several others said that, well, now all we have to do is increase the number of units on the keys, and that'll take care of the security aspect. They never even considered the speed aspect of things or changing that because by the time that I saw the problem, what everyone was talking about was that Bitcoin Lite was created, and everyone that was on Bitcoin still said that the long time for each block was part of the security, or something along those lines. So with regards to the security aspect, they weren't really scared of it. Now, with the time it would take to get that fixed, I still think it would be a concern, because how are you going to get all those people to agree on getting this changed quickly enough that you can actually get it changed and then actually get it implemented? I don't know. They're not that fast right now. But with other chains, especially more recent chains, the ones where, especially the ones that come out more recently, where you have where you have one guy or one team in charge of over 50% of the supply, yeah, you can easily do that. Just because they're going to vote, they're going to say, yeah, well, we're going to do this, we're going to make this change, they're going to implement the change, and it's going to be released. When they start off, they're very, very centralized because you have to be, you're in development mode. So yeah, the older chains, I don't see too big of an issue, but you have to move quickly. And I'm not too sure they're going to be moving quickly. Moving quickly is not in crypto with the older teams. With the newer teams, sure, especially with the VC money, they're going to be pushed to move fast when they're not paying for parties. But with the older teams, yeah, they're going to be a little bit slower.
So, all right. So if I understood, which I probably didn't, most of what you said, especially in terms of the numbers and let's say like the keys, right? So I think I understood that you're telling me like they'll have to increase the number of digits used on the public and private keys, right? That's something you said there. So like how much data are we talking about? If we have to start increasing the amount of digits and stuff like that for private and public keys, all just to make sure that what's it called, Shor's algorithm can't be reverse engineered. Like how much data are we talking about? How quickly will blocks fill up? Like how does that change the entire computational process for the blockchain, especially when it comes down to the hash sequences and coding them? Like it just seems to me that we might run out of capacity to handle all this extra data very quickly.
Well, let's say that you double the length of absolutely everything. We could expect it to fill up roughly twice as quickly. But most people aren't really worried about the size constraints on the blocks. Yeah, well, yeah, you have some arguments about increasing the size of the blocks so that way you can do more, or increasing the speed of the blocks. That way you can get them so you can increase throughput and move people through, move transactions through faster. To both ways of solving the problem. But if you double the size, then you basically move things back a year because what was it, Moore's law, something like that, where the power of computing doubles every year. Well, that's going to be with regards to what they can store as well, and just okay, you move back a year, but you've more than doubled the security. Because if you double the length, let's say what length are those strings? Like what, 60 characters? Well, that would be 256 to the 60th, something along those lines, and that's on top of what's already there.
It sounds about right. I don't know, because the way I'm doing the math, it sounds to me like this could take not double, maybe 10 to even 40 times more data to, and I'm just trying to think how that would, the blocks will fill up so quickly. And anyways, I don't know. This is one thing I'm just wondering, like, given the amount of computing power or electricity needed for a lot of this stuff now, how much worse is it going to get when we start adding data requirements to it? So, and we did mention this before, though. If we go back even to the fact that some of the chains do publish the public keys, right? That's one of the main concerns, right? Is that we said this in the earlier podcast. I think we said it was like, I don't know, somewhere like half of all of the Bitcoins out there and the Bitcoin transactions had public keys exposed or attached into it. Whereas Ethereum, I think it was like all of them, right? I think that was the main thing about Ethereum, is like all of their transactions have the public key baked into it. So, I mean, if you think about how much this is and having to go back and change all of this, like adding digits, I don't know. It seems like an insane, I'm thinking it's more 10 to 40 times more data. And that sounds like a lot.
Yeah, if you go through for the past, but if you're fixing up if you're fixing up the addressing and all of that, yeah, you're going to have to go back and fix up some things on that. How you do a migration of old addresses, I do not know for that. But at least anything new going forward, and you'd probably do a fork, move everyone over to the fork, and you'd have the new addressing system on there, which maps onto the old one in some manner. With regards to the public keys, as if they're tied to the old fork, you're not really going to be worried about it because everyone's on the new fork, and now the new fork is what has the value, not the old one. But the new keys, you'd not have to worry about the public keys there, because that's what public keys are for. They're public. You don't worry about that. It's you can't really get you can't really decrypt the private key from those. And if you could on the old one, the new one would have double the characters, and so instead of being 254 to the 60th, it would be 254 to the 120th. So yeah, you'd basically be secure again just with the fork, but you'd not worry about the old one. And yeah, there would be a history there, but you could, with what I remember, you would hash the last block, and then so that way every single time that you want to get to the previous block, then you'd have to decrypt that, and then you would decrypt the next block and before from that until you're back at block 1. But you'd also have the history of the entire blockchain stored somewhere, because people do that too. So you'd probably not have to. That would just be in order to create the continuation from the previous into the new. But yeah, you just what I'm pretty sure they would do is probably fork it so that way they could add the extra bits that they need.
So even with the forking, right? So I mean, it just comes to a point. I mean, you still have exposed transactions, exposed coins, exposed keys. You're gonna have it, like, no matter, even with the forking. At what point do we have to say, where the crypto community will have to just come to a vote and say, you know what, we need to burn all of Satoshi's original coins just to save the network from the quantum thieves? Like, because that to me is a reality here. It might have to come to a point that, especially at the speed at which, as you're talking about the speed before, David, you don't know how fast they're moving to fix this. At what point do you have to just say we have to burn a city to protect the rest of the world? I mean, it's pretty extreme, right? We're talking about like saying, let's just destroy half the Bitcoin supply or whatever, just to preserve the network to stop from quantum thieves taking over. I don't know. Like, is that a possibility?
Yeah, but if they can't move fast enough to fork it, I can't imagine they'd move fast enough to burn anything, and especially with the argument that would come from doing something like burning the creator's coins. So I'm not. If one's the problem, I don't imagine they'd be willing to do the other in good time.
Okay.
You'd probably just be screwed.
Yeah. The way.
Yeah. Yeah. Sorry. Yeah. Go ahead, Corey.
No, I was just going to say, the last thing I was going to say, to tell you that, like, one of my big concerns on this, is that one thing I don't think that we really have an idea of is, given how much more of a data requirement we're going to have. This, it's like this data bloat once we have quantum signatures incorporated into all of the transactions. I'm worried what's going to happen to gas fees. Like, I'm just worried that gas fees are going to explode as we start adding quantum protection to it.
Yeah, I completely agree. And with all like the data and encryption, right? Let's go back a little bit onto the topic itself, right? So we're talking about quantum networking and the quantum internet, right? A regular quantum computer already takes up a lot of power, right? So where are we going to get all of this source of power for when we onboard, let's say, the quantum network or the quantum internet, right? That is my big question right now.
Yeah, I'm just going to wait for Elon Musk to solve it for us, honestly. I mean, I think that's probably what's going to happen. I mean, we'll have some kind of orbiting solar platform and orbital solar panels that will just harness all the energy from the sun and power everything. I'm just waiting for Elon Musk to get around to that one. I think he's a little busy with some other projects in the meantime, but he'll get there.
Yeah.
Who knows? Honestly, I don't know. I mean,
David, yeah.
that's like.
Yeah.
Go ahead, Dave. No,
Yeah,
because I was just going to say, like, I think that's that's an entirely separate topic. It's just going to come to the point, energy sources for the future. How do we power the blockchain and AI data centers? And like, I think that's just that in itself is a topic that we can probably discuss for hours.
yeah, because we're already having trouble with like powering data centers with AI, and then we're gonna add like quantum computing to the infrastructure. It's just gonna really strain us. But
And you're
David,
already
what?
getting so much pushback from communities about data centers, right? So
Yeah.
what is it? New York State? Was it New York State? I think it was New York State just passed a law banning data centers now from the state. I
Mm,
know in Canada, we're getting a lot of resistance to some of the data centers that, Canada's really trying to make a push to become much more of a data center hub. And they're starting to see some pushback from communities.
okay.
I don't know.
David, what are your thoughts?
Well, yeah, a lot of people didn't like those, and then you had what was it, crackheads who were going in and stealing the copper, and people were saying, "Well, I didn't expect Florida man to be our savior," but yeah, you have a lot of people that are angry at those people who are pushed out of their homes because they're just bought up and paid for with data centers. People who are angry about having to pay for the electricity for data centers. Their electricity bills just go up mysteriously when data center is built nearby. You have people who are talking about how the rich are talking about these things and prioritizing data centers over them, well, yeah, you're going to get a lot of problems, and I don't see data centers as really a solution for much of anything. Just because, yeah, sure, you're probably going to need some data capacity. You could always lease that out from different places. But you remember how they used to hire a whole bunch of employees to look like they're growing, to just because yeah, look at our balance sheet. We're hiring all these people. We've got all these jobs and all these job boards. Look, we're growing. Look at this evidence. Well, I imagine that the data centers are probably something like that, and that they're not actually growing so fast that they need data centers all over the place. But that is probably just a way for them to throw money out and say, yes, you can still invest in us. We're growing. Look at all the data centers we're building. If we're going to have energy issues, I don't see that they're going to be too big. We're probably going to have larger issues with regards to cooling. And yeah, you could always throw them into space or something, but then how are you going to maintain them? But with regards to the energy side, that part's easy enough. Well, we could stop being so fearful of nuclear energy. Well, like a lot of people used
Fusion,
to.
fission.
What was that?
Or I was saying fusion or fission. I mean, because those are very different, like when you say you can't be scared of nuclear energy, I mean, there's plenty of reasons to be scared for nuclear energy. All right, we have
Yeah.
plenty of but the thing is, are we talking about just relying on typical fission technology, or are you saying like we really need to start pursuing nuclear fusion because it's clean?
I would
If
say
it's
fission,
possible.
because like fusion is still ways off, and so you're still going to have to get a larger population and better energy before you can get to that. Because any level of civilization requires a certain number of people and a certain amount of energy, like a certain amount of cheap energy. And fission is the next step towards of cheap energy, or at least, well, like probably there are probably some other ways that'll get you there slower. But with regards to this stuff, like the usual scary points are with regards to Fukushima and Chernobyl, and Chernobyl happened what, like 100 years ago? Well, we've gotten a few advances in technology between then and now. And yeah, let's say 60, let's say 40, let's say it was 40 years ago. We've had a few advances in technology between then and now. Blockchain being one of them. Like we're talking about Web 4 now, rather than Web 3. We've got rockets going up into outer space every other day through Elon Musk. Like we've gotten a few advances in technology. Maybe we've had some advances in the technology that we could use in nuclear reactors as well. Maybe it's a little bit safer, but like we've got these arguments for why these things are terrible, and meanwhile we're still using aircraft carriers, which are a 100-year technology, and I know that for a fact because I looked that up. And they're still the pride and joy of the U.S. military, and those use nuclear
Yeah.
power as well to make sure that they can still just power around all year long. So yeah, we've got some advances that we can use, and if they're in every single aircraft carrier and plenty of subs, so that way they can be quiet, like maybe we can use those to power a few city blocks.
I agree, and we've probably improved the safety protocols and everything, but there's always a risk. First off, I do have to point out Chernobyl was in 1986. It was not 100 years ago. Okay, I was 11 at the time. I don't think you guys were born yet for when Chernobyl happened. Okay, I was 11 when Chernobyl happened. I actually remember. I remember the news. I remember, when they would start saying, oh, yeah, the radioactive cloud was expected to pass over Montreal or whatever. I remember, yeah. So it was not 100 years ago. So, but I agree with that. I do think we probably have better safety protocols. But at the same time, I do think you're going to get way too much opposition to it. We already have, like we obviously need, I would love to see fusion, because it's clean. I also find it cool. But the one thing I would also say is I also find, look, I don't like betting against science. I do not like betting against humans and science. I'm not saying we won't wipe ourselves out with it, but what I am saying is that I would never bet against it. And, that's why I'm a big believer, like, you're never going to change human behavior. You're not going to be able to stop us from using fossil fuels. It's just not possible without doing catastrophic damage to civilization because of lost employment and power needs and everything. I personally am much believer that we will find a way to suck out methane and carbon dioxide and carbon monoxide from the atmosphere. But anyways, with the energy sources, so like hydro in theory should be plenty to be able to do this, but of course, you're talking about putting up dams, you're talking about doing more ecological damage, and of course, you do that. Many countries' sole water source comes from rivers that flow through other countries first. So, if Turkey were to ever decide to put a dam on the Euphrates or something like that, that means Iraq would never have water. So there's only so much you can do with the hydro side before you really start pissing people off. So there's that. I mean, then we're talking about the cooling. Yeah, space. How do you maintain it? This is why I was reading it would make more sense to put everything underwater. Again, not that doesn't have logistical and engineering challenges, but yeah, putting it underwater you're going to get a lot of opposition to that. I don't know what kind of ecological damage that can cause. I don't know what kind of pollution to the ocean putting the data centers there, but I think putting them underwater might be a little bit better than in space. But you never know. Maybe if we do put it in space, it also spearheads so many other technologies required to get us to space that it actually might improve all the other things that Elon Musk is working on in terms of eventually putting people on Mars or a base on the moon. I don't know, can we put the data centers on the moon? How hard could that be? We just need a few data centers and a golf course on the moon. I think, how much better my golf game would be if we reduced the effect of gravity.
You probably hit the ball into orbit.
Yeah, just launch the golf ball. If you guys never watched Seinfeld, I'd feel like I would be Kramer on the beach smacking golf balls until one lands into a whale's blowhole. But no, the energy, fusion to me is it's something we got to get to. It's the holy grail. We got to get to that for the energy source because I don't know. Everything's a trade-off. There's pros and cons to everything. Right. And it's just really trying to figure out the right balance and, of course, to balance out the needs that we have. But I don't know how sustainable it is. And that's part of the issue. I mean, we're growing so quickly in so many different areas that I don't know what the capacity or sustainability would be like. And the last thing we should ever do is just try and meet demand as quickly as possible without thinking about the future and how to scale it. But economic rationale is always an issue because people are going to try and make the quick buck as quickly as possible.
True. And let's get a little bit back on topic, right? So let's say in the future of quantum internet and quantum networking, right? What does this mean for the future of search? Because from what I know right now, 80% of the people I know currently use ChatGPT over any search engine, right? It's a lot faster. It's a lot, it summarizes your points. It writes based on how you want it to write. right? Instead of just giving you the links like the search engine, right? I know Google has rolled out, Gemini in their search engine, which does help a little bit. But at the
Yep.
same time, what does this really mean for the future of search, right?
Well, I mean, there's two different areas, right, to really consider that. One is just the current use of AI and stuff like that in web searches, and then how quantum networking, what the quantum internet will look like. So if we do, and like, yeah, right now, I mean, most of my searches, I still just go to I'm a Firefox user primarily, just because I always preferred Firefox for privacy versus Google Chrome. Like I use Google Chrome for pretty much when I'm using Google Colab or I'm doing something really requiring Google. Otherwise, I'm a big believer in Firefox. I've always loved it. I don't know what your guys preferred, unless you're on a Mac and you're using Safari. So I'll still just go to the address bar and type my search directly in there and let Gemini handle it. And yeah, very often I will, put in, Gemini has a terrible habit. Oh, would you like me to now show you this? I'm like, no, I want you to just answer my questions. So, and I will engage with it more to dive more into questions. But yeah, so that's all AI driven right now through that. So that's a huge improvement than just going through indexed searches. So when we start thinking about it at the quantum level, right? So quantum levels, it can flip completely how we find information. So if we think, and this goes back to, let's say, traditional web searches or even how you find anything, this is what's called the phone book problem, otherwise known as like Grover's algorithm. So imagine you're looking for a specific name in a phone book, if anyone even remembers what a phone book is. And let's say you had a million things in here, right? A classical search engine is essentially going to be looking through them one by one at various different algorithms or different ways to look at it one by one to find the closest match and then list them. That could take 500,000 steps, right? So those are time consuming and, depending on efficiency as well, how good the matches are. So Grover's algorithm, all right. So Grover's algorithm, if we had a quantum computer being able to do this, it wouldn't have to do this one at a time. It doesn't have to go one item. Oh, where does this one rank? Where does this one rank? It could use a mathematical shortcut that could pretty much compress the timeline exponentially. And this comes back to the whole superposition. It can do all of this at once instead of having to be sequential. So you could get it done in about 1,000 steps. So first and foremost is that quantum computing would speed up searches like crazy. And even compared to what AI is doing right now, this would speed up completely against the AI. I think the AI advantage is more just the quality of the results and having it more as like a dialogue as opposed to just looking up something in a phone book and getting the closest matches. So I think to me, that is what the major promise of quantum computing is here, is that it's going to greatly speed up the speeds of searches because of the principle of superposition, and it's not all linearly dependent or sequentially dependent. So that's my first take on what the future will look like with quantum computing applied to searches.
Okay, I completely agree. But what about, like, let's say how do you say, misinformation within? Is it that possible? Knowing that quantum computing is already, that powerful.
Well, I don't know if it'll necessarily alter, the potential for misinformation and everything like that. I mean, a lot of it is just going to be speed. And at the same time, though, I guess it can, because if you think about it, quantum searches will not require data to be perfectly categorized or indexed. Like if we go back to the classical one, I'll just stick with my example of using a phone book. If you don't have the person's name spelled correctly, or you put the first name instead of the last name based on your indexing, it's not going to work.
Yeah.
But quantum computing doesn't require that. It could instantly find anomalies or, optimize the entire chaotic structure that it's being forced to search through. So I guess it really all comes down to what the quality of the underlying data is in the first place. I mean, I don't see how it's going to make it worse or better. I don't know. David can correct me, because it's just changing how it searches and its efficiency. I don't know if it's going to be better or worse at filtering out wrong data.
Mm.
I don't know.
Yeah.
Maybe David knows more than I do there.
Because that's one thing you have to understand. It needs to like validate the data and the sources before anything it gives it to you. Because from what I've understand, it gives you mostly like, you know, it's based on the prompt and the relevancy of the prompt.
Yeah, but
David?
if you still have bad information in there, right? I mean, you talked about, because
Yeah.
your question was more about the misinformation.
Yeah.
So I don't see how that will change, or I'm just not seeing the effect here. David, I don't know. Dave, do you have an idea?
Well, I did check out Grover's algorithm, and that one looks rather nice. Basically, you get a superposition of everything, and then you check out which one matches. A square root of n speed algorithm, which is rather nice. With that, you get good speed. So let's assume quantum computing. You get a really good improvement on speed. You can get a really good improvement on speed for the AI. You can use both of those to serve up, check through, and feed back the information very, very quickly. That's all great. The AI does not know the information though, and whoever's searching doesn't know the information though. So they're probably not going to know if what's coming back to them is correct. The AI definitely doesn't know if what's coming back is correct, because that just goes based off of mass user opinion. Now, I looked up a couple of things just to make sure I had them right. PEBCAC is a term that is used that's used by a lot of software engineers. PEBCAK. Problem exists between computer and keyboard. You've got others like picnic, problem in chair, not in computer. ID10T, idiot, and code 18. The problem is 18 inches away from the monitor. Layer 8 error. Which is another, like, you've got a lot of these. And I think that the problem here would probably be very, very similar. Not in that the end user, the one doing the searching, would be the problem here, but the people who are doing, the people who are presenting the information. You have AIs over here, like I said before, you have AIs over here which allow you to do certain searches. You have AIs over in China that allow you to do certain other searches. And like, there's a little bit of overlap there. So you switch between the models that you want in order to get the information that is not going to be curated, but is going to be more likely to be correct. With regards to this stuff, we've got with regards to searches, we've got Google used to be great. Google used to be absolutely great at serving information. Then they started to change what came back to you based off of their preferences and what they wanted you to see. Now, that's even before they got into ad serving. And, well, no, ads came first. Very, very slight ones on the side. But then later on, like, they started to curate what you were allowed to see. And you don't know whether or not they're doing that. Because if it doesn't come up on the first, it used to be said that if it doesn't come up on the first page of Google, it doesn't exist. Well, if they remove that, if they just derank that or remove it entirely, you don't know that that thing existed before, because you're searching for it for a reason. Now, if you're searching for it in order to find it so that way you can, because you've seen it before and so you can hand it over to someone else, yeah, you'd know that it's missing. But if you're searching up the information for the first time, you have no idea, and most people have no idea when they're searching for something for the first time. This is why Google used to be an authoritative source, and why AI is the authoritative source now. I don't think that the problem is going to be with the algorithm, and I don't think it's going to be solved by the algorithm. I think that the problem is with the people.
So, yeah, I think that's, I mean, that comes back to, yeah, pretty much that's exactly what I was saying, that, you know, the Grover's algorithm and all this is going to improve the speed and everything like that. But, you know, ultimately, I think you would need to really combine it with other elements of quantum computing to start improving the search results and to reduce misinformation. Like, if you can start getting better machine learning algorithms using quantum computing, I think that's where you'll get better results there. I think you need to combine the quantum search technology with other benefits from quantum computing, such as machine learning algorithms and other, detection mechanisms. I think that's where you'll get a massive improvement on reducing false information.
One of the things I was actually I just had a thought when David said, like, Google has a preference of what you want to see, right? So
Yeah.
most people are using AI as a search engine, right? One of the things how does this really affect like SEO for like businesses or just even in general?
Oh, it's completely changed. It's completely changed because, and this is actually something I was giving a talk about a month ago at the Canadian Investor Relations Institute's annual conference, just up around Montreal. And this actually came up is like, how does it, in the age of AI and AI searches, how does this change like how you run your website, your investor relations part of your website? And there was the thing that I was saying is like, you've moved away from what we've called search engine optimization, and it's now AI engine optimization kind of thing. So you're actually changing the way you write your content and the way you are, you're not as reliant necessarily on the metadata tags and everything like that. But what you are doing now is you're absolutely writing your content in such a way, knowing what people are going to be looking for in an AI. So in other words, they're going to go to the AI, tell me about this company and whether it's a good time to invest. I mean, that's a very broad, like that's not a way you would want to do it. But let's say or you anticipate people saying, tell me about this company's current sales cycle, what product. Okay, well, now based on pretty much terms that people are looking for in AI, the content that you're going to want to put up there to make sure that the correct message is getting to the AI. So that when people go to the AI, ask the question, they are seeing what you want them to see, or at least the correct things. So SEO is massively changed because now that people are searching through AI, you have to write your content based on knowing people are looking at you through an LLM now and not through a traditional Google search.
Yeah. And I think we actually talked about this topic in a previous episode where it was synthetic media in the digital age, right? Where we also talked about, how businesses really need to get their own sense of authenticity when it comes to stuff like this.
Yeah, I think that's exactly it. So, I mean, it's really, plus it's just the authenticity and everything like that, the synthetic data. I mean, we are looking at a fundamental transformation in terms like from the whole digital marketing point of view. This is a major transformation that people need to adapt to in terms of knowing that most people are searching from an AI nowadays, or even searching through Google, it's going through Gemini. So it changes everything. It changes the nature of everything. So, I mean, think about the way you guys do it. At what point, look at it this way. Imagine you do this one of two ways. You're interested in something. Let's say you're not shopping right now, or maybe you are. It can work for that too. At what point is a simple search, even knowing it goes through an LLM, at what point is your simple search not enough, where you're going to want to go to the LLM, open a chat, and have a full-scale chat about a specific topic instead of doing a basic search? Or even, let's say, I'm going on vacation next week. I need to buy new sandals. What kind of sandals should I buy? So at what point would you just do a web search? Or at what point would you go to the LLM and open a chat? Obviously, if it's a massive purchase that you want to look into reviews, you're probably going to go straight to Claude or Gemini, open a chat, and have the dialogue. So think about the way behavior is now altered. Think about the way you work. At what point do you go to an LLM and open a chat as compared to just doing a search in the Google bar? Think about how often do you do both? What's your normal process now?
That's actually a good question. I don't remember the last time I actually used the Google search bar. Like I can go through my chat GPT tabs on my phone and it's just like endless. You can literally see like the entire history of what I've done. And
Me too.
I think I have more history on like ChatGPT than I have on like my actual browser, OpenGX.
Yeah, I'm not surprised by that at all because I think I'm pretty much the same way. I mean, I do a lot of Google searches and stuff like that, but you know, the way I'm typically doing it is I will say it's going to be like a one sentence kind of thing. Do this, tell me this, explain this, or whatever. But the second I know I might be needing more information or it's a really important kind of purchase, like planning a vacation, and I love doing the planning, like doing my itineraries through LLMs now. I love it. And that way you can, you know, eventually have your itinerary created. It's stored inside the LLM and you're walking down the street in the middle of Italy. You could interact with Claude and say, hey, I'm at the corner of here and here. Where's my next stop and how do I get there? You know, I find that that kind of integration is fantastic. But, you know, so let's say, for example, I was just looking into buying a new guitar. That's clearly something I did on an LLM. You know,
Yeah.
this is what I'm looking for, the kind of wood, the kind of sound, you know. So, but I would say 90% of everything I do nowadays is through an LLM compared to a search bar.
Yeah.
And
I completely
that changes everything. I mean, companies, you know, you need to adapt to that because it's now making sure that your customers get the correct information, not that they find you per se. It's also if they do find you, what information are people seeing, and how do you make sure that it's what you want them to see?
completely agree. And I think we're already coming up to an hour, if I'm not mistaken, Cordell. You want to end off, episode 22 today?
I've been doing it the past couple of weeks. It's David's turn, man. You're closing off this week, Dave.
Hey, David?
I can't say I'm the best people person, but sure. Well, that's been it for this episode of Crypto and Coffee. We've gone over cryptography and how it might impact things in the future, and hope to see you on the next episode. Thanks. Bye.
Yep, great closing, Dave.
Yeah, I think so. Not a people person. Nobody out there believes that for a second. All right, everyone. Thank you. We'll see you in a couple of weeks.
All right, see you guys.